This Zoom session is being brought to you by the Fractal Cybernetic. All right, for today, we'll be doing sections 1.5 and 1.6. 1.5 is about solving linear equations by transposition. 1.6 is about solving formulas. Okay, the solution of an equation is the value of the variables that makes the equation true. So for example, 2x minus 1 equals 13. It's true for the value x equals 7. Because when you substitute 7 in, you get twice 7 minus 1 is 14 minus 1 is 13, equals the right side. You check solutions by this kind of substitution, but the question is how to find solutions, which is in fact most of what algebra is about, finding solutions to equations. Okay, now in this case, here we have an equation 2x minus 1 equals 13. Ax plus b equals c, where constants a, b, and c. What's x? That's called a linear equation because later we'll see that the graph is a straight line. Now we'll solve them by two equivalent methods. What the book calls equation rules, what is also known as transposition. For example, if two numbers are equal, then if you add the same number to both sides, they'll still be equal. Also, if you subtract the same number from both sides, they'll be equal. Multiplying both by c will be equal. Dividing both sides by c, they'll be equal. Their opposites are equal, and their reciprocals are equal. Equal operations on both sides of an equation yields an equation. The idea is we'll use this to simplify equations. Okay. Here's another way of looking at it. If we have x plus a equals b, then we can use the equation rules and subtract a from both sides. But then, since a minus a equals 0, they cancel out on this side, and you just get x equals b minus a. So x plus a equals b implies that x is b minus a. This is called transposition. The idea being that a changes the place from one side of the equation to the other. So here x plus a equals e, we subtract a from both sides and get x equals b minus a. If x minus a equals b, we add a to both sides. And again, a's cancel, and we get x equals b plus a. X times a equals b, divide both sides by a, and a cancels on the left, and we get x equals b over a. X over a equals b, multiply both sides by a, and get x equals b times a. Minus x equals b, take the opposite of both sides, and since the opposite of x equals x, it cancels on the left, and on the right you get x equals minus b. And 1 over x equals b, if you take reciprocal of both sides, since on the left you get 1 over x, which equals x, so you get x on the left and 1 over b to the right. Transposition. So on each of these, a flips from one side of the equation to the other. It's the same number a, but the operator flips, plus to minus, minus to plus, times to divide, and divide to times. Oh, for this one, there's a difficulty about, we have to say that stipulate that a is not 0, because dividing by 0 causes problems. All right, and let's see. Oh wow! So now we solve equations I use equation rules and transposition to isolate the variable. For example, 2x equals 34 for what x? Well, here's a 2 in front of the x times x, so we do divide both sides by 2. And so we get x equals 34 over 2, so x equals 17. X plus 2 equals 34, we subtract 2 from both sides. Get x equals 34 minus 2, or x equals 32. If x over 2 equals 34, then we multiply both sides by 2. The 2 cancels on the left. Get x equals 34 times 2, which means x equals 68. And if x minus 2 equals 34, we add 2 to both sides. Get x equals 34 plus 2, so x equals 36. Now here's one where, here we just use one transposition. Here we're going to have to use several. 2x plus 3, that divided by 4. All that minus 5 equals 6 for what x? All right, well, first, the general rule is you look at x, and you see what operations were done from them, and then the last one done, we do the opposite of. So here, minus 5 is the last thing done. So we add 5 to both sides. That cancels it on this side. And on the right side, you get 6 plus 5. So 2x plus 3 over 4 equals 6 plus 5, and that's 11. Now, here, x times 2 plus 3 over 4. Dividing by 4 is the last thing done on this side. So we multiply both sides by 4. Cancels on the left, you get 2x plus 3. On the right, you get 11 times 4. So 2x plus 3 equals 44. 2x plus 3, we undo the plus 3 by subtracting 3 from both sides. It cancels on the left, leaving only 2x. So 2x equals 44 minus 3. That's 41. And last step, x is times 2, so the opposite is dividing by 2. So x equals 41 over 2, and x is 20.5. All right. Here we have negative 1 over x equals 5/4. I take reciprocal of both sides. That'll flip this into x over negative 1 and 4 over 5. And then here we have a division by negative 1. We undo that by multiplying both sides by negative 1. It cancels on the left. We're left with x equals minus 4 over 5. All right, here we have some others. 60t minus 50 equals 15t minus 5. Now here the difficulty is that the variable t is on both sides of the equation. And you want it to be t equals number. So it doesn't do if the variable is still on the other side of the equation by the time you're done. And also, of course, you want the constants all over to the right and the 15t to the left. So we transpose 15t to the left by subtracting from both sides. We transpose 50 to the right by adding it to both sides. These cancel on their sides, and you get on the left 60t minus 15t. On the right, minus 5 plus 50 here. So 60t minus 15t equals minus 5 plus 50. After a bit of simplifying, 45t equals 45. To isolate t, we undo times 45, so we divide both sides by 45. It cancels on the left. You get t equals 45 over 45, which means that t equals 1. Here, 2x plus 3 over 3 plus 3x minus 4 over 6 equals, z minus 2 over 2. It's a little early to use any transposition because it's such an awful mess. I mean, particularly it has these denominators 3, 4, and 2. However, the lowest common multiple of 3, 6, and 2 is 6. So I'll multiply throughout by 6 to cancel the denominators. Multiply every term by 6. 6 times 2x plus 3 over 3 plus 6 times 3x minus 4 over 6 equals 6 times z minus 2 over 2. 6 over 3 is a 2. That cancels. 6 over 6 cancels entirely. 6 over 2 is a 3. So twice 2z plus 3 plus 3z minus 4 equals 3 times z minus 2. Okay, we distribute the 2 over this and this. 4z plus 6. This is still 3z minus 4. Distribute this. 3 times z, 3 times negative 2. 3z minus 6. 4z plus 6 plus 3z minus 4 equals 3z minus 6. All right, we're going to move the 6 and the minus 4 to the right by subtracting 6 and adding 4 to both sides. We'll move the 3z to the left by subtracting 3z from both sides. The 6 and the minus 4 will cancel on the left. The 3z will cancel on the right. What we'll be left with is 4z plus 3z minus 3z equals minus 6 plus 4. Okay, and after this count, after some simplifying, you get 4z equals negative 8. And then divide both sides by 4. Get z equals minus 8 over 4. So z equals negative 2. Okay. Here's one that's going to try of a type that causes trouble. Twice x minus 3 equals 3 halves of x minus 4 plus x over 2. Now, again, we have these denominators 2 and 2. They're annoying. So we'll get rid of them by multiplying throughout by 2. This then times the 2, this gets a 4. 4 times x minus 3 equals, times the 2, this becomes a 3. 3 times x minus 4, plus twice x over 2 is x. 4 times x minus 3 equals 3 times x minus 4 plus x. Now we distribute the 4 over this and the 3 over this. 4x minus 12 equals 3x, again minus 12, plus x. Now, we'll move this 12 to the right by adding it to both sides. Move this 3x and this x to the left by subtracting them from both sides. Result, 4x minus 3x minus x equals minus 12 plus 12. Now, unfortunately, when you simplify, what happens is you get 0x equals 0. And now we're in trouble. Now, there's two ways to proceed from here. If we just sort of multiply, and in general, 0 times anything is 0. So this really reduces to 0 equals 0. That's true. It's called a tautology. But for that very reason, it tells you absolutely nothing about x. It's not even in the equation. Another way to look at it is if you try to transpose a 0, which is sort of a naughty, you get x equals 0 over 0. But 0 over 0 is the indefinite ratio and equal any number. So this, you got either this or this. Both ways say that this equation is true for any number x. So it's what's called an identity. These are identical values. But it also means that there's no way to, well, let's see, this doesn't specify a value of x. That's the trouble. Now let's try this. Negative 3x equals negative 2x plus 1 minus the quantity 5 plus x. I would distribute the negative. Minus 3x equals minus 2x plus 1 minus 5 minus x. We'll move the 2x and the x both sides. We'll add both sides. Negative 3x plus 2x plus x equals 1 minus 5. After simplifying, you get 0x equals negative 4. Up here, you get 0x equals 0. Any x solves this. Here, we'll see that no x solves it, because 0x is 0, and this therefore says that 0 equals negative 4. Is 0 equal to negative 4? No. No. So this is a contradiction. This is never true for any value of x. A contradiction. Or conversely, we could divide by 0 and get x equals negative 4 over 0. But non-zero divided by 0 is an infinite ratio. Taken either way, no finite value of x solves this equation, so it's a contradiction. I get an absurdity either way, so the original equation must have been absurd. So this is an equation with no solutions, and this is with an equation with nothing but solutions. And both aren't quite what you want. You want an equation with one and only one solution. So this is too much. The tautology is too much, and the contradiction is too little. Now here we have 5/2 a minus 12 equals 1/3 a plus 1. Well, okay, division is always the most annoying operation. So you have a 2 and a 3. To get rid of them, let's rescale by their product, 6. So multiply throughout by 6. 6 times 5 over 2a minus 6 times 12 equals 6 over 3a plus 6 times 1. Work out 6 times 5 over 2, it's 15, 15a minus 6 times 12 is 72, 15a minus 72 equals 6/3 a is 2a plus 6 times 1 is 6. 15a minus 72 equals 2a plus 6. I will transpose the 72 to the right by adding 72 to both sides. We'll transpose the 2a to the left by subtracting 2a from both sides. So you get on the left 15a minus 2a, and on the right 6 plus 72. Therefore 13a equals 78. Divide both sides by 13 and get a equals 78 over 13. And that means a equals 6. So that's the solution, a equals 6. Here, This is one that's 2 parentheses deep. All right, fine. -4 times p minus parent, 3 minus p, n parent, equals 3 times parent, 6p minus 2. First thing we'll do is we'll dissolve this innermost parentheses by distributing the negative. -4 times p minus 3 minus a negative p, which is plus p. On the right, we distribute the 3. 3 times 6p is 18p. 3 times minus 2 is minus 6. Next step is to distribute the -4 over these. So you get -4p. -4 times -3 is positive 12. -4 times p is -4p, equals 18p minus 6. I will move the 12 to the right by subtracting it from both sides. Move the 18p to the left by subtracting it from both sides. So you get 4p minus 4p minus 18p on this side. On the other side, minus 6 minus 12.
Excuse me, teacher. I don't understand why, if it is minus 4p and then 3, why it became a 6 in the parentheses. First is 3 and then it became 6.
Here's my cursor. Where do I move it? Up or down or left or right?
Mhm.
What 6? This 6?
No, in the first, when you're explaining up there.
Up.
Yeah, there.
Here.
Down. No. Then 95, that is -4 parentheses p minus parentheses 3 minus p parentheses.
Yes.
Equal, then is 3 parentheses 6p minus 2.
Distribute 3 over these two terms. 3 times 6p is 18p. 3 times -2 is minus 6.
Thank you.
No problem. All right, here we go. We got, I believe we got this far. Right, and so we subtract 18p from both sides. We subtract 12 from both sides. So we get minus 4p minus 4p minus 18p on the left equals minus 6 minus 12 on the right. After simplifying, minus 26p equals -18. All right, so we divide both sides by -26 to get p equals -18 over -26. The negatives cancel, a factor of 2 cancels, so p equals 9/13 is the answer to this problem. Okay, here's another one where there's annoying denominators, 5 and 5 and 2. The lowest common multiple is 10. So let's multiply throughout by 10. 10 times t minus 2 over 5 plus 10 times 5t equals 10 times 7 over 5 minus 10 times t minus 2 over 2. 10/5 cancels, leaves a 2 here. 10 stays there. 10/5 is a 4, well, is a 2 times 7 is 14. 10 over 2 is a 5. So 2 times t minus 2 plus, this multiplies out to 50t. 10 times 7 over 5 is 14. And 10 over 2 is a 5 times t minus 2. Now let's distribute the 2 over here and the 5 over here. So here's 2t minus 4 here plus 50t equals 14. And then minus 5 times t is minus 5t. And then minus 5 times -2 is positive 10 because negative times negative is plus. Okay, let's move the 4 to the right by adding it to both sides. Let's move the the 5t to the left by adding it to both sides. So you get 2t plus 50t plus 5t on the left equals 14 plus 10 plus 4 on the right. After some simplifying, 57t equals 28, and divide by 57, t equals 28 over 57. All right. Let's stop.